One of the most powerful ways to increase productivity is to automate. In today's video, you'll learn how to set up a continuous integration and delivery pipeline for a Firebase app using Google Cloud Build. By the end of this video, you'll be able to test, build, and deploy your app to Firebase by simply committing your code to GitHub. If you're new here, like and subscribe, and follow along with the source code on Fireship.io. You'll find additional pro tips and pointers in the full write-up. So what is CI/CD, or DevOps as it's commonly called? It really just boils down to automating anything and everything that you can between writing your code and deploying it to production. This results in a whole wide range of benefits, but most importantly, it keeps your development code as close as possible to your production code. So how does that work? Well, it starts with a Git repo. Whenever you commit code to this repo, it will trigger a new build. A build is just a Docker container running in the cloud that does many of the same things that you would do locally, like install your npm dependencies, test, build, and deploy to Firebase. This is exactly what we do for Fireship.io, in addition to other things like updating our search index on Algolia, etc. If the build fails at any step, it will not deploy the final code and will know exactly where the problem lies. And Cloud Build will give us detailed logs that we can hopefully use to find the root of the problem. So getting all this stuff set up is kind of painful in the beginning, but once you have it set up, you'll be very glad that you did. For Fireship.io, it pushes new code and content to the site almost every day, and even as an independent developer, this saves me a ton of time, but just imagine how much time that would save a large team. The adoption of CI/CD has been kind of a macro trend for the last few years, and there's a lot of really good services out there like Travis and Circle. So what are the advantages of Google Cloud Build? The first obvious one is pricing. It offers 120 minutes of free build time per day, which is probably way more than you need, but if you exceed it, it becomes pay-as-you-go after that. Other CI services generally have a free tier, but then it becomes a monthly fee after that, which is usually over $50 a month. And because it's integrated with GCP, it's really easy to connect other services. For example, we can just add IAM permissions to deploy to Firebase hosting. In this video, I'll show you how to work with IAM, but I'll also show you how to encrypt your environment if you want to use tokens from external services, which is required by a large number of apps. To get started, you can use any front end that you want. It can be Angular, Vue, or React, or whatever. Then you'll also need a Firebase project, which automatically comes with a Google Cloud project. And then you'll need to install the gcloud command line tools. From there, you'll need some kind of front end app. In this case, I'm just generating a Vue.js app. The only real requirement is that it's a JavaScript app using npm. And it should have scripts that we can automate, like a testing script and a build script. From there, I'm going to initialize Firebase in this project. In this demo, we'll only be using hosting, but you could also use this to deploy your cloud functions as well. So I've just made some slight modifications to the default Vue app, and this is what we want to deploy automatically. The next step is to set up a Git repo. We could use cloud source repositories on GCP, but in this case, we'll be using GitHub. Bitbucket is also an option. Go ahead and create the repo, and then push some initial code to it. Then in the command line, we'll just run a git add, git commit. Then we'll connect our local code to the remote repository. You can see those commands on the GitHub repo itself, so just copy and paste those, and then we should be good to go. Now, I'm going to show you two different ways to configure Firebase with Cloud Build. The first one is very simple by just configuring IAM roles, and the second one will actually configure a fully encrypted environment that you can use to also encrypt other third-party APIs like, say, Algolia, SendGrid, etc. So let's start by enabling Cloud Build on GCP. After that, go to the IAM page, which stands for Identity Access Management. You'll see the service account for Cloud Build, and by default, it doesn't have access to our Firebase project. We can do that by editing the permissions and adding a role for Firebase admin, as well as the API keys admin. And optionally, you can add the KMS crypto key decryptor, but that one's only needed if you use the encrypted environment that I'll show you towards the end of this video. So now that we have our permissions set up, we need to tell Cloud Build the actual steps involved in building, testing, and deploying our app. In order to do that in the cloud, we need to have some sort of execution environment, which we do with Docker containers. These are called builder images, and they just give you access to very common commands like the npm command or git, go, etc. But you'll notice that the Firebase command is missing from this list. If the command you need is missing from that list, you'll want to go to the community maintained builders repo. This is where we can find the Firebase builder, and what we'll want to do is clone this repo and then deploy our own image to our GCP project. This is actually really easy. We just clone the repo, then we cd into the Firebase directory, and then we'll run gcloud build submit. And this will save the image to the container registry on our GCP project. So this allows us to run the Firebase deploy command and have the right permissions context that we set up in IAM. You can verify that that worked by going to the container registry on GCP, and you should see the image there. From there, you can just go ahead and delete the community builders repo from your local system if you want to clean things up. Now we're to the fun part where we actually get to define our CI/CD pipeline. Create a cloudbuild.yaml file in the root of the project. It contains an array of steps where each step is a part of your build process. You'll notice the first property is a name, which points to the actual command that you want to run. And then args is an array of whatever you want to add to that command. So in this case, it's like running npm install. In this Vue app, we have 4 steps. First, we run npm install, then we run our unit tests, then we run npm build. And you'll notice for all those steps, we use the built-in npm cloud builder. But for our deploy step, we're actually using our Firebase container, so we pass in an environment variable for the project ID/Firebase. And keep in mind, there's a whole bunch of different options you can pass to these steps to customize the way they behave. So that defines our build. The next step is to tell GCP to listen to our GitHub repository. So go to the Create Trigger tab and then click GitHub and then choose your repo from the list. And also keep in mind that GCP has a plugin that you can install directly in GitHub to do this stuff automatically, but it's fairly limited at this point, so I want to show you the full process. You can trigger your build on different branches or tags, and for now we're just going to keep it simple and trigger it on everything. That's good for testing your code, but you probably don't want to deploy on anything but the master branch. So check out the full article, I have some code that shows you how to do that. And also make sure to tell it to use the cloud build YAML file and not a Docker file. Now it's time for the moment of truth. Create another git commit and then run git push origin master to push it to GitHub. And then you should see the build run automatically in the cloud build page. For an app like this, it should only take a minute or two, and it will log out everything that's going on directly in the console. It's pretty common to get errors at this point, so if you do, make sure to check the logs and it should tell you exactly what went wrong. But hopefully you see all green, and when you go to the actual URL, you see your final deployed production code. And keep in mind, if you do run into problems, you can always submit builds directly from the command line or directly from the console, so you don't have to always commit your code to Git just to trigger a build. Now, the next thing I want to show you is a little more advanced, and that's how to create an encrypted environment for your build. In this example, we're not going to rely on the IAM permissions, but instead use the Firebase CI token. This approach has the advantage of being able to scale to other secrets or API keys in your environment, and it also means we don't need to use that Firebase builder image, so you can skip that step if you want to go this route. Install Firebase tools in your development environment, then run Firebase login CI. That will give you a token that you can use to authenticate the cloud build server for your project. From there, create a .env file. This is where we'll save all of our environment variables. And keep in mind, you'll have sensitive secrets in here, so you don't want to expose this in a public Git repo or any other public format. Now that we have our token, we'll go ahead and define a new deploy script in the package.json file. It just runs Firebase deploy, and then we'll pass in the token option and point it to that environment variable. At this point, we need a secure way to get our local secrets to our CI server. We'll do this by encoding them with a cryptographic key. This means we'll be able to put our encrypted secrets in a public Git repo, but only services that have the proper permission will be able to decode them. The first thing I want to do is create a key ring. We'll call it my project, and it's able to hold multiple keys or multiple encrypted files in a single context. In our case, we want to encrypt the entire environment file. So we'll give that key a name of cloud build env. Then we can just keep the default options for everything else. From there, we'll go back to our project and we'll run gcloud kms encrypt. We're telling it to encrypt our local environment file as a new file called env.enc. This file is encrypted, so it's perfectly fine to put in your Git repo. Now we need to update our cloud build file. The first thing we'll want to do is decrypt our environment secrets. Because cloud build has access to the crypto key decryptor IAM role, it can use that .env file just like we would locally, so it has access to all of the same environment variables that we do. Currently, that's just the Firebase token, but in a larger project, you'll probably have multiple third-party APIs that you need to manage. The other change we'll want to make is take out the Firebase deploy command in favor of the npm run deploy command. Go ahead and commit these changes to GitHub, and you should see a new build populate. And if you go into Firebase hosting, you should now see Cloud Build as the service account running the deployments. So hopefully this showed you that automation is pretty awesome. And make sure to grab the full article from Fireship.io to just copy and paste all these commands. Leave me a comment if you have any questions or feedback. Thanks for watching, and I will talk to you soon.